Hey, all right. So you can, whichever problem you got wrong, you can go ahead and move around in this video and find out the ones you got wrong and figure out how to do them correctly. Okay. I'm going to just be setting up the proportions and giving you the answers. I'm not necessarily going to be showing you how to solve the whole thing. The setup is really the most important part. Okay. Getting those proportions just right so that you can solve them. I hope that you have the skill of solving them, but setting them up is the part that's getting you messed up. Okay, we have a shadow reckoning problem to start, and we have a flagpole and a mailbox. All right, we got the flagpole and the mailbox. All right, they give us the heights of both, which is weird. Usually they don't give us one of the heights. The mailbox casts a shadow that is 5.25 feet. How long is the flagpole shadow? I don't know why we would have to figure out why we would care how long someone's shadow is. Usually we'd be like, oh well, we want to tell the height of this flagpole because we need to buy the rope for it or something like that. But all right, is what it is. I don't know that these problems sometimes don't make any sense. Okay, but the idea is the same. We compare their heights, 30 to 3.5. And then we compare their shadows, x to 525. Okay. And then when we do our cross multiplication and division, we get 45 feet as the length of the shadow of
Hey, Judah, do you know how to wash your hair? Do you know how to wash your
the, what was it now? Flagpole. Okay, number 4. Okay, so we have another shadow issue. We've got the high school that is 20 feet tall, 25 feet tall. We have the service drop box, which is 4 feet tall. The drop box casts a 6-foot shadow. At the same time, what is the length of the school building shadow? You can get a measuring tool. Like, why are we using indirect measurement to do something that we can measure ourselves? It's just silly. Sorry, that's 4 feet tall and 6 feet. So that's going to be 25 to 4, right? We compare both their heights and make that ratio. And then we've got x to 6, make that ratio. And the answer is going to be 37.5 feet. Moving on, number 5. Okay, careful here. Number 5, we have to pay attention to these angles. That's to help us figure out which pieces are corresponding. I like to always figure out, find the x, find what I'm missing. Okay, it does say to find x. And then I have to figure out the corresponding side. I know that this has 3 dashes and this corner has 1 dash. So I got to find the other side on the similar triangle that has 3 dashes and 1 dash, which is this. So these two side lengths are the corresponding side lengths. So we can say x to 40, right? The missing side to the 40. And then I got to go from this shape. Since I started with x for my first ratio, I have to start with a piece of that same shape. So that's going to be 105. And what does 105 correspond with? It corresponds with the 35 over here. And when I solve that proportion, I get 120 yards. All right. Number 6. Now, this is a little different. You see how the corresponding sides were on the same side, like the left side of both these triangles? This one is drawn a little bit differently in that the corresponding sides are going to be kind of on opposite sides of the triangles. Anyway, so we're going from Athens to Yukon. That's here to here. All right. So that's what we're finding. So I'm going to compare this one, and then its corresponding side on the smaller triangle would be the line that connects the double arc to the single arc. So double arc to single arc, that's here. That would be there. So we have x to 16 is equal to, now we got to find corresponding pairs that actually give us the numbers. So since we went big to small before, we got to go big to small for our second ratio, and that gets us the corresponding side of 14. And the answer to 6 is 40 miles. That's a far way to measure indirectly. All right. Number 7. Okay, we got shadow reckoning here, and we have the height of the roller coaster is 157.5 feet. And oh, good, they tell us the roller coaster shadow. What? These problems are ridiculous. How long will a person's shadow be if the person is 5 foot 3 inches tall? 5 foot 3 inches. Now, we can't do very good math with 5 foot 3 inches. We need a decimal, and it'd be 3/12 of a foot, right? 5 and 3/12 of a foot, because 3 inches is 3 out of 12. So then that's going to simplify down to 1/4, which would be 5.25. Okay, so instead of 5 foot 3 inches, we are simply going to put 5.25 feet. And now we can figure out that shadow length. Really important to know someone's shadow length. That's why we're learning this important math. Anyway, we can do the relationship between their heights, 157.5 to 5.25. And so that one like that. So this goes like this, 60 to x. Now, on other problems, I've said to put like find the x and do that first. So you could have done x to 60 equals. So if I go that way, then I'd have to do 5.25 to 157.5. But that's going to work just as well. Okay, and my answer to this one would be 2 feet, a 2 foot shadow. All right. Number 8 was a doozy. And I tried to review it with you in class. If you didn't get it, now's your time. Now's your chance, okay? I showed you that it helped me to kind of break it up into a large, medium, and small triangle. We know that this one's 4.5 by 6. I don't know if that helps putting those in. Anyway, so the first thing we're going to find the measure of GD. So that's this measure here, and I forgot to label this 9. Okay, well, this big guy is similar to this little guy, and we're looking for that. So we go x to 6 is equal to 9 to 4, right? X to 6, 9 to 4.5, I guess that should be. All right, and so for that one, when we solve that, we get 12. So now we know that this whole length is 12. All right, from here to here is 12. Now, it says if segment GF is congruent to segment FE, GF and FE are congruent. Okay, well, all that's telling me is that this would have to be 3 and this would have to be 3. Because what's 3 plus 3 plus 6? 3 plus 3 plus 6. 3 plus 3 plus 6 is 12, the whole length. All right, and why do we need that? Why do we care what these are? Well, because we have to find the measurement of BF, which is this guy here, and we can't get him unless we know at least one of the side lengths of this mid-sized triangle. So now we know that this was 6 and this was 3. Right, I'm over here on my phone. Anyway, 3 and 6. So therefore, this bottom is 9. So we can then find this missing piece because we could relate it to the other pieces, the other similar triangles, right? So if we call this x again, then we'll relate x to 4.5. Make the ratio of corresponding pieces, and 9 to 6. And that gives us an answer of 6.75 meters. All right, wow. Okay, and then if the length of segment AD is 15, so A to D all the way there, that's 15. What are the lengths of the segments BC and CD? BC, B to C, and C to D. Okay, well, wow. You know what? I'm going to have to find, let me erase some of these. A couple ways you can do it, but I'm sure you guys gave it a good try. All right, so we now know that this is 15, 9, and 12. And what are we looking for? This is CD on the little one, so we can get that one now. I can figure that one out. You want to know why? Because if I'm making that X, I'm trying to figure out CD, then I just have to find a corresponding side. So I could do X and 15. And then 6 and 12. How about that? 6 and 12. Okay. Oh, look at that. I see that the scale factor there is times 2. That's cool. So right here is times 2. Anyway, when we do the cross multiplication, we find that CD comes to 7.5. So CD equals 7.5. Now, I don't have to do any math for that other piece because if I know that this whole thing, oh man, and that's 7.5. Oh, actually, I do have to do some more math. But it's not too bad. Actually, it's terrible. It's really frustrating. Okay. We're going to find the whole thing here. And then we're going to subtract the 7.5. Okay, we found out that that's 7.5. So if we find the whole thing and minus that, we'll get this piece here, which is what we're looking for. All right. So let's go. What was this, 9? Okay, so, and then we'll make that our X. So X to 15, 9 to 12, and when we do that, we get a weird number of 12.25, I think. And then we got to subtract the 7.5. And we get a crazy number here of 3.75. Wow. Okay. Got it? So this here is 3.75. That was a lot. And it wasn't easy. Hopefully some of you, at least some of you got it. That won't be anything that's on a test. Now this next one is crazy too. All right. Number 9, you had to draw a diagram. There's your runway. We have a biplane that starts to take off from the beginning of the runway. I'll call this the beginning. And here's the end. Okay, it starts to take off, and it is 500 feet. All right, there's my biplane. All right, biplane is taking off. It's 500 feet, and a bird is flying in the same direction. Okay, and it is 15 feet from the beginning of the runway. So 15 feet from the beginning of the runway, and it is 8 feet above the ground. Okay, here's my little birdie. 8 feet is right there. Okay, so we got all the piece of information, and I'm guessing that this is supposed to be our setup of our triangle. All right, so what are we trying to figure out? Draw a diagram, write and solve a proportion to find how far the plane is from the beginning of the runway. All right, so this here is 15. It's a little confusing the way I wrote it to. Okay, so we're wondering what this length is right there. So if we start with the x, we go x to 15 equals 500 to 8. Okay, x to 15, 500 to 8. And then when we solve that, it gets us 937.5 feet. Whew, okay. Keeping it moving. Okay, electrical poles that carry electrical wire seem to get smaller the further away they are from you. Find the apparent height of each pole. So that's what it looks like to you. It's not its actual height. If the tallest pole is 50 feet and the distance between each pole is 100. All right. So we got to find the height of each one. All right, let's do this. Okay. So this is 400. And we're just going to do a variety of, so this is 100 right here. This would be 200, and this would be 300. Okay, so we just have to set up a proportion for all those. The tallest pole is 50, so let's just do this. We got to find each height, so let's call it X, Y, and Z. Okay, one proportion would be, let's do X first. So X to 50 equals 300 to 400. All right. Y to 50 equals 200 to 400. And Z to 50 equals 100 to 400. And when you solve all of those, you get first pole is 50, the second pole is 37.5, the third pole is 25, and the fourth pole is 12.5. Okay, so those are our setups. All right, and we're moving on to number 11. All right, we got these guys in position. Josh is 16 feet from Devin. So we got 16 feet right there. And and Devin is 5.5 feet from Marco. Josh. It's 5 1/3 feet. Just a matter of labeling this. All right. If Marco is 4 feet from both, okay, 4 feet from both A and B. how wide is the key? So that's this distance here. I'm not sure if you know what a key is, but okay, well, the 5 1/3, sorry, so we're looking for that. We're looking for D. I like to start with that and put D, and what it corresponds with is 16. And since we went from smaller triangle to bigger triangle, we'll go smaller triangle of 4, and that corresponds with the 5 1/3. Okay, and when we cross multiply, there we get 12 feet as the width of the key. 12. Hopefully you're not watching this whole thing because it's taking me forever to get through them. Use the figure height. Write two different proportions that could be determined. Could determine the height of the lighthouse. All right. Well, we know that this down here is 9 feet. Okay, that's just a different way to write it. But if we want to do it how I've been doing it and put the x, just start with the x, what you're finding, then we can go x to 15 equals 120 to 9. Okay, lighthouse to regular house, x to 15, and then so we have to do that again. So this bottom part for the lighthouse compared to this bottom part for the house, right, would be 120 to 9. Lots of different ways we could do it, though. We could just flip that over, do it small to big, and so then that would be small to big. Okay, we change the order of the fractions. There's lots of different ways you can do that one. And then when we look at how tall the lighthouse is, we get 200 feet. (13) We have a Ferris wheel that is 100 feet tall and it's casting a shadow. So 150 feet tall, casts a 37.5-foot shadow. What's the height of a woman standing nearby? What's the height of a woman that casts a 1.5-foot shadow? So if we start with x, we'll go x to 150, and we'll go 1.5, easier to type in the calculator, and 37.5. Okay, when we solve that, it comes to that woman is 6 foot tall. Last one, thank goodness. 14. All right, a tree house casts a shadow of 18 feet, while Jeanette casts a shadow. Oh, I wrote the wrong thing. While Jeanette casts a shadow of 9 feet. If Jeanette is 5 feet tall, how tall is the treehouse? Well, that one might be one that you don't have to do much math because you can see that it's just double. So that could be just double. If you need the proportion, it'd be x over 5 equals 18 over 9. And then when you solve it, the treehouse is 10 feet tall. All right. Whew. Hopefully that was a little bit helpful. If not, I am so sorry that it took up that much time.